Let's talk about the very foundation of our world. That simple on or off switch. But what if we broke it? What if we dared to think about a totally new kind of computing? One that moves from the classic bits we all know and trust to the daring qubits of tomorrow. Now, this question right here, it's not just some nice-sounding poetry. It's actually the key. You see, our entire digital reality is built on single, separate notes. But a new kind of machine, it thinks in chords. It holds multiple possibilities, all at the same time. And that's the core of what we're about to unpack. So here's a promise I'm going to make to you. If you stick with me for just the next few minutes, the way you see computing, and honestly, maybe even reality itself, is going to shift. It's time we unlocked a new way of thinking. Okay, first things first, let's ground ourselves in what we already know. Think about our classical computers. I want you to think of their logic as this: beautiful, but ultimately really simple monotone melody. Think about your phone, your laptop. Deep inside, there are literally billions of microscopic transistors firing away. They are the tiny, tireless heartbeat behind every single call you make, every song on your playlist, every thought you type out. And their tune? It's incredibly simple. Each of these little switches, which we call a bit, has only two states. That's it. It's on, a 1, or it's off, a 0. A simple binary choice. It's rigid, it's absolute. And because of this, classical computing power grows exactly how you'd expect it to. You add more bits, you get more power. It's just one steady, predictable step at a time. There's no real magic to it, just clean, simple math. So, here's a little thought experiment for you. If you double your bits, what happens to your power? The answer is pretty simple, right? It doubles. That's the classical mind at work. Step by step, logical. Now, I want you to hold on to that thought, because the music, it's about to change completely. So forget that predictable growth. We are about to enter a world that doesn't play by the old rules. This is the world of the qubit. And this is where the jazz begins. So what in the world is a qubit? Well, it's the quantum version of a bit. But here is the one thing, the only thing you really need to remember. It isn't locked into being just a 0 or a 1. It can be a 0, a 1, or, get this, both at the exact same time. This incredibly strange and powerful property has a name: superposition. I mean, just look at the contrast here. A classical bit is like a single rigid note. But a qubit is like a spinning coin. While it's still in the air before it lands, is it heads or is it tails? In a way, it's both. It exists in this liquid state of pure potential, holding both possibilities at once. And this single difference, this amazing ability to exist in superposition, is what leads to an absolutely unbelievable explosion in computing power. This isn't a steady march anymore. It's an exponential crescendo. Because a qubit can hold multiple values, adding another one doesn't just add power. It multiplies it exponentially. This right here is where the song fundamentally changes. And this table is what that really means. Let's just look at this together. So at 10 units, okay, the number of states is the same, around 1,000. No big deal. Now, look at the bottom row. Follow me here. With 30 bits, a classical computer can be in one of about 1 billion states. That's a lot. But a quantum computer with 30 qubits, well, it can explore all 1 billion of those states simultaneously at the same time. So you see, this isn't just about being faster. That is such a critical point. It is not the same machine just revved up. It's a completely different kind of thinking. It's not the same song played faster. It's an entirely new symphony. But here's the twist. Of course there's a twist. All this quantum magic, this symphony of possibilities, it has to eventually give us a clear answer that we can actually understand. And this is where the song collapses. So while the quantum computer is actually doing its work, its qubits are in that beautiful symphony of superposition. They're holding every possible answer. Every single interwoven harmony, all at once. The whole system just holds this shimmering potential. 1,000, 1,000,000, 1,000,000,000 interwoven possibilities are all held in motion. But we can't see them. It's a world of pure potential, just waiting for us to ask for the answer. And here it is, the final, crucial piece of the puzzle. The moment we measure, the moment we look at the qubit to get an answer, that spinning coin finally lands. The symphony of possibilities collapses, snapping back to a single, definite note, a 0 or a 1. All that quantum magic resolves into a classical answer we can actually use. And just like that, you've grasped the fundamental difference. You've unlocked a new harmony in your own understanding of how things can work. So, let's nail down the key takeaways. Just remember this. Classical bits are locked. They're rigid. Qubits are liquid, full of potential. That potential, that superposition, is exactly why they can explore these vast mazes of problems all at once. And maybe most importantly, every quantum journey has to end with a classical result, a solid bridge back to the world we know and understand. So you've now heard the opening chord of a revolution. You understand the fundamental shift from a single note to this rich, complex harmony. You've seen the potential. The only question left is, now that you've heard the first chord, are you ready for the full song?